Hey guys, this is 5.4. We're going to be introducing polynomial functions and then like being able to identify some vocabulary around them, and then we're going to add them and subtract them. Thank you for watching. All right, we're going to begin with just what is a polynomial function. So we know, right? We know that function is denoted by f of x, right? This means that if we do the vertical line test and we were to graph this, which isn't, if we were to graph this, because it's a polynomial function, it will pass the vertical line test. There aren't going to be two different answers for an x that we choose. If we say that q is worth 1 and r is worth 0 and s is worth 2, we're always going to get the same answer. That's what a function means, right? And we went over that last unit. Polynomial, poly just means many. And nomial just means number, okay? And we know function just means f of x. All polynomial functions are in the general form. This is confusing, okay? Note this right now. There is an n, a non-negative whole number. Highlight this. These are the n's, okay? The ones that cannot be negative are these up here. I said n, and then I highlighted the number 1 and the number 0 because those are also exponents, so I didn't need to highlight them. But I just want you to see that we're talking about when the exponent is a non-negative whole number. 1 is also a non-negative whole number, and 0 is a non-negative whole number. So I guess I can highlight them, but we're just saying that all of the exponents are going to be positive. Non-negative means positive or 0. Remember, when you have something raised to the power of 0, you just have the number 1, okay? So all polynomial functions are of the general form an minus 1, an minus 2, a1, a0. A is the coefficient for the associated variable. The coefficient is the number in front of the letter. The number in front of the variable, okay? I feel like I now need a purple highlighter, right? So a to the n, or sorry, an is the number in front of the variable. If this is confusing, that's okay. Just use colors. Don't worry about the an minus 1, an minus 2, how it's written, okay? I just want you to be able to imagine that there is a number. All those are numbers in front of the letter x, okay? This is some number. This is some number. This is some number. This is doesn't even have to be a different number. They can all be the same number. We're just saying numbers in front of the variable, and they can be positive or negative. Your exponents are never going to be positive or negative, but the number in front of the variable can be positive or negative, okay? So what does it mean, all of these n minus 1s, n minus 2s, 1s and 0s, n minus 1, n minus 2? They're just saying put it in descending order, okay? Descending order just means take the biggest, this part's the important part. In descending order, take the biggest one. Take the biggest one and put it in front, okay? So I'm going to give you an example. If I have, we know it's a polynomial function, so I can start with f of x equals, okay? Or you don't even need to put anything. You can just start with the number, whatever number I start with, 5x to the 3rd plus 2x to the 4th minus 4x, good, plus 10 minus 3x to the 5th, okay? There's my example polynomial. Now, here are the purple parts, right? It's just a number in front of the x. That's a purple part. That's purple. that -4 is purple. Make sure you remember that the sign goes with the number, that +10 is purple, and that -3 is purple, okay? So that's what we're talking about. In descending order is the exponents, okay? Here's my exponent of 3, exponent of 4, exponent of 5. Why did I highlight above the 4x and the 10? Because I want you to see that, I wish I had a ruler. I want you to see that we said x to the power of 0 is 1. So what I'm saying is +10 alone, just the number +10, is the same as 10 times x to the power of 0, because we remember x to the power of 0 is 1, 10 times 1 is 10. Okay, so that net plus 10 is actually our last number times x to the power of 0, and it's our constant. Okay, constant is down here. This one's the constant, the constant, the constant. This one's the constant. It's just a 10. Okay, so x to the power of 0 is the same as 1. 1 times 10 is just 10. Okay, and then -4x, the x doesn't have any power, but anything to the power of 1 is itself, right? So I'm also going to say that 4x is the same as 4x to the power of 1. Okay, so in descending order means we always end with our constant. Good. And then the next biggest one goes in front of that. And then it's going to be, there is no x to the power of 2. There just isn't one, and that's fine. No problem. But the next biggest one is x to the power of 3. Then we have x to the power of 4 and x to the power of 5. So in descending order are going down. In descending order, 5, 4, 3, 2, 1, right? Are the exponents. I'm not worried about if this is negative or positive, and I'm not worried about if this is smaller than or bigger than this one, okay? I want to know if this one is smaller than or bigger than this one, all the way down until I get to my constant, which is, in this case, 10, because it's the same as 10 times x to the power of 0, and we're putting those x to the power ofs in descending order. So after 1 will be 0. All right, so let's rearrange this based on what I just told you. Right now we say f of x is equal to 5x cubed plus 2x to the 4th minus 4x plus 10 minus 3x to the 5th. Okay, I'm even going to rewrite it and include that x to the power of 1 and the 10x to the power of 0. You don't have to. You can leave it as a constant because we're more familiar with 10 than 10x to the power of 0, so that's fine. 5x to the 3rd plus 2x to the 4th minus 4x to the 1st plus 10x to the 0, power of 0, minus 3x to the 5th. Okay? Now I'm going to rearrange them so that the exponents are in descending order. Before I do that, just to cover everything, remember I said purple? The purple is, in this case, the 5, not the x. It's the number in front of the variable. It doesn't count the variable. So that 5 is a purple. That positive 2 is a purple. Always include the sign in front of it. The -4 is a purple. The positive 10 is a purple. And the -3 is a purple. Okay? Okay. So those are our coefficients. The 10 is a coefficient as well as a constant. Okay, so we're going to call that one a constant because really I made up I put this there to make it a coefficient, but it's more a constant. Okay, so it's purple and blue, but it's better blue. All right, so the number in front of the x, not the x, is the coefficient. All right, it doesn't matter if the x is actually a q or an r or an s. Okay, now that we have, here we have a coefficient of 5, a variable of x a power of 3, coefficient of positive 2, exponent of 4, coefficient of negative 4, exponent of 1, constant of 10. Okay, we're going to call this a constant. Coefficient of negative 3 is a coefficient because there is an x being multiplied by it. It's a constant if it's not being multiplied by any x value. And remember, x to the power of 0 is 1, so that's not really an x value, so that's the constant. Constant, coefficient, 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 coefficient. Okay, now let's put, and obviously exponent, 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 exponent. Let's put the exponents in descending order, but I'm going to start in the back. I know that the smallest number here is 0, right? X times 10 to the power of 0 is the same as 10. So I'm just going to put a 10 at the end. All right. So that's x to the power of 0. Then we're going to have x to the power of 1. There's 5, 0, 1. Negative 4x. We know that 10 was a positive, so I'm going to put a plus in front of the 10. Negative 4x to the first. We do not need to include the 1 because we know it, right? If there's no 1, if there's no number above the x, it's just x to the power of 1. So you can put the 1 or not, doesn't matter, okay? Now, 0, 1, n minus 2, n minus 1, and n, it just means n is whatever number you started with, the biggest one. In this case, n is the 5, right? Our biggest number is 5. 5 minus 1 is 4. 5 minus 2 is 3. And you keep going down. These dot, dot, dots mean if we started at 100, so here's 5x to the power of 100, plus 5x to the power of 99, plus 5x to the power of 98, plus da, 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 da. You're going to have a lot of numbers in between here before you get to 5x plus 5. So whatever number you start with is the number n. And then we just go in descending order, means we take n, and then the next number smaller than n, and then the number closest to n, the number biggest after n. You know, there's a lot of ways to say it. N, the next biggest one, until you get to just a plain x, and then your constant. Good. So we don't even need to know our n. We just need to, I think it's easier to count from 0, 1. What's the next biggest number? 2. There's no 2. 3. There's a 3. That's a positive 5x. So I'm going to say plus 5x to the third. So I have 0, 1, 3. What comes after 3? 4. We're only looking up here, and here's a 4. Plus 2x to the fourth. And then we have 5. Negative, very important that we see that, negative 3x to the fifth. Good. So that's that same equation, but now I've put it in descending order, which is what the n minus 1, n minus 2, 1, 0 means, okay? 5 minus 1, 5 minus 2. It's okay that there's no 5 minus 3, 5 minus 4, 5 minus 5. Good. So that's what those symbols mean. We have our number in front of the variable, and it's okay if that number is negative, doesn't matter. These numbers cannot be negative. These numbers cannot be negative, but these numbers can be negative or positive, fractions, decimals, whatever, okay? All right, so just so we know that, now we know what we're saying when we say a polynomial function. All right, so given the polynomial 10q squared r squared minus s cubed plus 15 minus 12r squared, what are the variable terms? Okay. The variable terms are each term. How many are there? The variable terms are between, what color should I use? Between the plus and the minus sign. Okay, so each term being added or subtracted to each other is a variable term. Good. So this is our first term. Again, I'm answering letter A. What are our variable terms? 10q squared r squared is my first term, okay? My next term is, and we need to use the sign if the sign is negative. My next term is negative s cubed, okay? My next term is negative 12r squared, okay? 15 is not a term because a term means, right, that you're going to have variables and coefficients. What is the constant? I guess it shouldn't be purple, right? The constant is the number 15. It's a positive 15, so I'm just writing it as 15, okay? So we have that term negative s cubed, and that term negative 12r squared. I don't want to make this too cluttered, but I just wanted to make sure you saw where I was getting those. C asks us the coefficients, okay? So remember that the coefficient is in front of, number in front of the variable, okay? So for part C, or sorry, for 10q squared r squared, we're not going to include the variable. The variable is the letter. We don't need either of the letters. We just want the number 10, okay? Our next term was negative s cubed. Well, s is the variable, but I have a negative sign. Is there a number in front of s? Remember, just like up here, if there's no number associated with the exponent, we say it's an exponent of 1, right? If there's no number in front of the s, it's still being multiplied by 1, right? How many s's are there? There's one s, but it's a negative 1s. How many q squared r squareds are there? There are 10. How many s cubeds are there? There are negative 1 of them, okay? How many r squareds are there? There were negative 12 r squareds, okay? Okay, now they're asking us what is the degree of a term and what is the degree of a polynomial. The degree is, you can say that this is q squared, for example, or you could say it's q raised to the second power or q raised to the second degree, okay? So the degree of a term is the sum of the exponents of all the variables in the term. If a term only has one variable, the degree equals the exponent. Okay, let's look at this. Let's go back to mine, okay? 5x to the third, the degree is 3. Here, I'm going to go like this. I'm going to do the degree of each one. Okay? So the degree of 5x to the third is 3. The degree of 2x to the fourth is 4. The degree of negative 4x to the power of 1 is a degree 1. The degree of 10 is, there is no degree. The degree of negative 3x to the fifth is 5, okay? So when you only have one you only have one variable, your degree is going to be the same number as your exponent. Degree 3, degree 4, degree 1, degree 5. Okay, so that's a term because each term, right, is each individual variable between the plus and the minus. So this is two variables grouped together with a coefficient. That's one term. One term, one term, okay? So if a term has one variable, the degree equals the exponent, but if not, the degree of a term is the sum, add all exponents of variables in the term. Okay, maybe two examples. If I have, we're not worried about the number, but I'm just going to put a number in front just to clarify or to confuse, right? 5x y squared, and I'll say it's x squared y squared, has a degree of 4 because we added all the exponents in the term. X had 2, Y had 2, it's a degree 4. All right. If it was just changing this number, but that number makes no difference, 10x y, I want you to think about this. It's a hard one. Remember, if you just see the letter x, that's actually x to the first, y to the first, so that's a degree 2 polynomial. Okay, so you're adding all the exponents of the variables in the term. 4x squared y to the 5th z. That is degree. We're just adding them, okay? We're going to add 2 and 5 is 7. Don't forget that if that letter is there, it's a degree 1. So 2 and 5 is 7, but that z makes an 8th degree term. I put that, like I was going to put them all right here, but that would have crammed it. So that's why the colon is there. If a term has more than one variable, darn it. I thought that was a different question. The degree of a polynomial is the largest degree of any term in the polynomial. New color. Largest degree of any term in the polynomial. Okay. So if I put all of these together, if it was 5x squared y squared plus 10xy plus 4x squared y to the 5th z, right? I think I would have to put this one first because remember we decided that this was a degree, the degree of the terms. This is a 4th degree, that's a 2 degree, that's an 8th degree. And so the largest degree of any term in the polynomial, this is an 8th degree polynomial. So the entire polynomial is a degree 8. And we're going to put it in descending order. So we're going to change it to 4x squared y to the 5th z. And then we're going to go to our 4th plus 5x squared y squared plus 10. And I'm just going to say xy. I'm not going to say x to the power of 1, y to the power of 1. Okay, it's doing degree 8, and I've put it in descending order again. Good. All right. Find the degree of the polynomial and determine whether it is a monomial, binomial, trinomial, or none of these. Quick note on what is a monomial, binomial, trinomial, or none. Monomial, binomial. Notice that they're all ending in the same with the same letters. Nomial, just like polynomial. Oh, sorry. Poly means many, and nomial means number. Good. Binomial, trinomial, or none. Polynomial. Okay. A monomial has one term, such as x to the 5th. A binomial has 2 terms. Bi means 2, mon 1. So x to the 5th plus 10xy. Polynomial has, trinomial has 3 terms. X to the 5th plus 10xy minus 4y. Trinomial because there are three terms. First term, second term, third term in descending order because this is x to the fifth, that's x to the 1, y to the 1, y to the 1. Okay? Polynomial means many. Good. X to the fifth plus 10xy minus 4y plus 6. Good. A constant is a term. Okay, a constant is a term that does not change. So over here, we said the variable terms. We had three variable terms. We had one constant, but we had four terms. So this is a four-term polynomial. So it's not a trinomial, okay? A trinomial looks like this, or a trinomial could look like this, as simple as x squared plus x plus 1, okay? A constant is a term. A binomial could be as simple as x plus 1. Good. A monomial could just be x. Okay, the constant is a term. It's not a variable term, but it is a term. 1, 2, 3, 1, 2, 3. Pen doesn't work, I'm throwing it away. Let's now practice. What is the degree of the polynomial, and is it a monomial, binomial, trinomial, or none? Hold on, my computer's about to die. All right, hopefully the microphone's still plugged in. All right, let's find the degree of the polynomial and decide whether it is monomial, one term, binomial, two terms, trinomial, three terms, or none. Okay, we're just counting up the terms. And we are also counting up the exponents of each term so we can decide what the degree of the entire polynomial is. This is just the number -9 a to the 6th. That is a monomial. And it has a degree 6. Good. Number 4, 1, 2, 3 different terms between the plus signs. Positive 14y to the third, positive 4y squared, positive 6. So those are three terms. Trinomial. Degree. This one was easy because we only had one variable and it was raised to the power of 6. Here we have a variable raised to the power of 3, variable raised to the power of 2, and a constant, right? So we take the term with the biggest variable, degree 3. Here we have 1, 2, so that's a binomial. What degree is it? This is a degree 2, because it's just one variable raised to the second power. Here we have -9 times x times y times z, and remember, each of those letters means that it is being raised to the first power. X to the first, y to the first, z to the first. So that is 3 degrees for that term. This is a term of degree 3, and so this is a polynomial of degree. Which one's bigger, x squared or x, y, z? This has a bigger degree, degree 3. Ooh, number 6 is a big one. 7xyz minus 9y squared z cubed plus 20xy minus x squared y squared z squared. Good. Let's find the degree of each term, okay? Just like we did here. We said that this was degree 4, this is degree 2, and this is degree 8. Yeah, let's do that here because it's a bigger one. X to the power of 1, y to the power of 1, z to the power of 1, that's a degree 3. Y squared, z to the third, we add 2 and 3 and we get 5. X to the power of 1, y to the power of 1, that's a degree 2. X squared, y squared, z squared, 2, 4, 6, that's a degree 6. Okay, so now that we have the degree of each term, which one's the biggest degree? This one. So this is not a binomial, 1, 2. Is it a trinomial? 1, 2, 3? No. Is it a monomial? 1? No, it's none. And it is degree 6. Okay. Once you found the degree, you also know how to put it in descending order. So if I were to put this in descending order, I would start with this one. Remember, it's a negative. They didn't ask us to put it in descending order, but I just want to give you some practice. Negative x squared, y squared, z squared. Then we're going to go to our 5. Again, it's a negative 9y squared, z cubed. And then this is a 3. So we're going to go to plus. That's a positive 7. 7xyz. And then plus 20xy. So that would be in order. Number 7, this is degree 0. Is it a monomial? I'm sorry. You couldn't even see that. So the number 8 has a degree 0 because remember 8 is the same as 8 times x to the power of 0. And so it's a degree 0, and I guess it's a monomial. Okay. Number 8 is asking if p of x equals x squared plus 2x minus 7, find p of 5. This just means instead of x, we're going to input 5 for x in p of x equals x squared plus 2x minus 7. Good? All right, so instead of x, we're going to do 5. Should give myself more space. But anyway, so that means p of 5 is 5 squared plus 2 times 5 minus 7. So instead of that x, I got a 5. Instead of that x, I got a 5. Let's simplify. P of 5 is 5 times 5 is 25. 2 times 5 is 10. Minus 7. 25 and 10 is 35. And you're welcome to throw it in your calculator. But eventually we get 35 minus 7 is 28. P of 5 is 28. Good? Okay, so that's just simplifying a polynomial function. What does, number 9 asks us to review like terms. What does like terms mean when we have variables? The like terms means that the variables are exactly the same and the exponents are exactly the same, okay? Terms with the same variables. Terms are anything between those operation signs, right? Not multiplication or division, but anything between plus and minus. The terms with the same variable, exact same variable, raised to exactly the same exponent. Power, okay? When do you combine like terms and when do you use the exponent rules from 5.1, 5.2? So when do we use the exponent rules and when do we use combining like terms? It's a good question, right? Exponent rules are for multiplying and dividing. Okay, so if you have to multiply or divide the terms, use the exponent rules. And then you combine like terms. When you add or subtract terms. So if you are adding or subtracting combine like terms, if you are multiplying or dividing, use exponent rules. All right. Okay. Simplify this by combining the like terms. Okay. We are not using exponent rules. We are just combining like terms. Make sure that your terms are truly alike. Combining like terms, terms with the same variable raised to the same exponent. We are not looking for the same coefficient. We are not looking for the same number in front. Oh, I'm so sorry. We are not looking for the same number in front of the y. We are looking for the same variable y raised to the exact same exponent. So y to the third and y to the third are like terms. Okay. Down here, y and y, or y raised to the first and y raised to the first, are the same term. Okay. Here, negative 14x minus 15 plus 5 plus 4x, those are the like terms. And the constants can be combined together too, because we know that negative 15 and 5 go together. We can put that into our calculator and it will give us a number, right? Down here, we have x squared, x, x, and x. Those are not all like terms, okay? So let's keep going with the like terms. And it's just like if we were adding the negative 15 and the 5. Okay, maybe we'll just do that first. Negative 15 and 5 is going to be negative 10 because the signs are different. 15 and 5, we can combine them, but the signs are different. A negative and a positive means we subtract. 15 minus 5 is 10. And then we take the sign of the bigger of the two numbers. The 15 is bigger than the 5, and so 15 was negative, so it's a negative 10. Or you put it in your calculator. Negative 15 plus 5 is negative 10. Good. Combine like terms the exact same way. You keep the like term, so it's going to be an x, and then you combine the negative 14 and the 4. Remember, you're only adding or subtracting. You're not multiplying or dividing when we're doing like terms with polynomials, okay? So we have negative 14 and 4, just like the negative 15 and 5. You're totally welcome to put it in your calculator. Negative 14 plus 4, or you can say they have different signs, so I'm going to subtract them and make the answer, give the answer the sign of the bigger number, negative 10. So negative 4x minus 15 plus 5 plus 4x is negative 10x minus 10. I put the constant at the end because we always put it in descending order of degree, right? This is degree 1. And that's degree 0. We want it in descending order. That's combining like terms. Negative 7y plus 7y. Negative 7 plus 7 is, it's just 0y, or just 0, because 0 times anything is 0. Negative 7 plus 7. Here, so we kept the x, right? And combined the negative 14 and the 4. We kept the y and combined the negative 7 and the 7. So here we're going to keep the y to the third and say 14 minus 4 is 10 y to the third. We had 14 y to the thirds. We took away 4 of the y to the thirds and we had 10 y to the thirds. Right? So if I had 14 of them, all right, so when we combine like terms, what we're actually doing is we're taking 14y cubed and we're taking away 4 of them. 1, 2, 3, 4, right? And what are we left with? 10y cubed. We had negative 7y's, we added 7y's, we're left with 0, right? Because that's the opposite of that one. Negative 15 and 5 is negative 10. Negative 14x plus 4x is negative 10x. Good. All right, we said that these are not all like terms. Why? Because though they have the same x, the same variable, they do not, all the variables are not raised to the same power. So this is raised to the second power, this is raised to the power of 1, power of 1, power of 1, right? So we're going to leave the negative 4x squared like that. We're going to leave the negative 4x squared because there are no other like terms to combine it with. And then we're going to say negative 3x plus 5x minus 9x. I would just put in my calculator. Negative 3 plus 5 minus 9 gives me negative 7x. So those terms are not alike. They don't get combined. Here we have negative 8r minus 12r to the 6 minus 3r to the 6 plus 12r. I also like to group. Again, make sure that you're keeping the negative sign with the coefficient. Good. All right. You don't have to do this because it might make it more confusing for you, but now I've put them together so it's easier to combine them. I know that the r to the 6 and the r to the 6 are like terms, and I know that just the r to the first and r to the first are like terms. So I grouped them. I put these two here, negative 12 minus 3, and I put these two here, positive 12 minus 8. Good. Negative 12 minus 3. You're just adding them and keeping it negative. 12 and 3 is 15, but they were negative to start with, so it's negative 15 r to the 6th. That never changes because we're just adding and subtracting. We're just adding and subtracting, so it's always going to be y to the 3rd. It's just how many. 12 minus 8 is going to be a positive number because the 12 is bigger than 8. 12 minus 8 is 4. Don't forget the variable, okay? Ooh, decimals, don't worry, just throw the decimals in your calculator, okay? We're still looking for like terms. So this term is x to the 3rd. This is a different term, so I'm going to use a different color. This term is x. This is a constant. This term is x. So this x I made orange, so I'm going to make this x orange. X to the 3rd is like that first one, 3.9x to the 3rd. And then negative 8.1 is a constant, which I guess we can denote them as like terms. Good? Okay, so if you want, you can now put them in order. 3.9x to the 3rd minus x to the 3rd. When I just have minus x to the 3rd, what is that the same as? How many x to the 3rds? Negative 1x to the 3rd. I almost called it x squared. So 3.9 minus x to the 3rd is the same as 3.9 x to the 3rd minus 1x to the 3rd. Okay. I didn't have to cross that out, but I get real messy. Good. Okay. That was the highest degree, degree 3. So I'm going to go to the next highest degree, negative 6, 0.4x plus 1.8x. And then I'm going to go to my constant, plus 11.3, because the constant has the smallest degree, right? Degree 0 minus 8.1. Again, now we're just going to combine like terms. 3.9 minus 1 is going to give us 2.9x cubed. Negative 6.4 plus 1.8 gives us negative 4.6 x. And then 11.3 minus 8.1 gives us 3.2, positive 3.2, no variable. Good, so that's the simplified version. 17 is going to be a mistake, and I want you to decide what went wrong, okay? They're still just asking us to combine like terms, but there's a mistake in this one. the quantity 19x minus 10 minus the quantity 6x plus 13 is simplified to 25x minus 23 incorrectly. What did they do? They said 19x minus 10 minus 6x plus 13. Where is the mistake? The mistake is a very common mistake that people make in all of algebra, not just this class. To carry, you need to carry or distribute. You need to distribute the minus sign. I like to look at it as a -1. Okay, so I'm going to rewrite it so that we don't make the mistake of not distributing the -1. 19x minus 10 does not need parentheses because nothing is happening to the 19x minus 10. There's no minus in front of it. There's no 7 in front of it that would cause us to multiply it by the 7. There's just 19x minus 10. However, here we have the negative being distributed to the 6x plus 13, or we're going to subtract 6x plus 13 from 19x minus 10. So minus 6x plus 13 combined is like multiplying both the 6x and the positive 13 by a -1. So I'm going to, instead of a minus, I'm going to put a -1 times 6x plus 13. Now I can remember that this needs to be distributed. So I would again rewrite it as 19x minus 10 minus 6x minus 13. And then I can combine like terms. 19x minus 6x. Oh, they also just weirdly added those. Okay. 19x minus 6x. You think it's 15? 19x minus 6. 13. Ooh, Callie. That's why I like calculators. 13x, -10 minus 13. You're just adding those, okay? 10 and 13 is 23, but you're both negative, so it's going to be minus 23. Oh, that's weird. They got the wrong answer in a weird way. All right. Oh, okay. So, maybe we're supposed to talk about each problem. So this one, well, anyway, here's the right way to do it. I don't know how you get that. And then from 19x minus 6x, you get 25. And from -10 plus 13, you get 23. Anyway. Okay. Here, however, 3x plus 3 plus 12x minus 8. Again, the parentheses mean we need to distribute the plus sign, but the plus is just a positive 1. Positive 1 times 12x is 12x. Positive 1 times -8 is -8. So we rewrite this as itself. 3x plus 3, get rid of those parentheses because there's nothing around them. There's nothing to do to that. Plus 1 times 12x and 1 times -8. Or plus 12x minus 8. 1 times 12x is still a positive 12x. 1 times -8 is still a -8. Okay, so you can just drop the parentheses because it's an addition. You don't need to distribute an addition sign. Or there's no change when you distribute an addition sign. There's a change when you distribute a subtraction sign. Good. Now we're just combining like terms. 3x is like terms with positive 12x. And then 3 is like terms with -8. So 12x and 3x is 15x, because they're both positive. And then positive 3 minus 8 is a -5. Good. Again, it's a plus sign, so you don't need to worry about the parentheses. You can kind of ignore, you can definitely ignore the parentheses because there's no number and there's no minus sign in front of it. So I'm just going to rewrite it as -7y plus 8 minus 3y squared, right? Because that was a plus the -3y squared, plus a negative is the same as a minus, plus positive 5y plus -2. And now we just look and see what like terms do I see. I see -7y and positive 5y. I see positive 8 and -2. And then I just see -3y squared. You also want to put it in descending order. So I see that this has a degree of 1, degree of 0, degree of 2, degree of 1, degree of 0. So I'm going to start with my degree of 2, because it's the biggest one. It's the biggest degree. The 7 isn't, or sorry, the -3 isn't the biggest number, but the exponent is the biggest. The exponent is what determines the degree. The degree is how we put it in descending order. Good. The 3 was a -3, so make sure you carry the negative sign, okay? What's the next largest degree? -7y has a degree of 1 and is like terms with +5y. And then the last one is a degree 0 of 8 minus 2, okay? This is going to carry over a little bit. So that just becomes 3, or just like get too big for its little box. -3y squared minus 2y plus 6. Done. Here, we need to distribute the negative, just like we distributed this negative. Distribute the negative, okay? So we rewrite it as 2x squared plus 10, because there was nothing to distribute through those parentheses, -1 You don't have to think about it like this, if it doesn't help you, but if it doesn't help you. Only think about it this way if it helps you. You need to distribute the minus sign. You can just say, I'm going to switch that sign. I'm going to switch that sign. Or you can say, I'm going to multiply this number by -1, and I'm going to multiply this number by -1. I'm going to flip the sign. I'm going to flip the sign, or I'm going to distribute a -1. I'm going to distribute a -1. Either way, you're doing the same thing. Okay. 2x squared plus 10. Now we're adding -1 times a positive 15x squared. Negative times a positive is a negative. So plus a negative is the same as a minus. And then -1 times a positive 5 is a -5. Good. All right, now we can combine like terms. 2x squared minus 15x squared plus 10 minus 5. 2 minus 15, you can subtract. 15 minus 2 is 13. The 15 was negative, so the 13 is going to be negative. 10 minus 5 is 5. Okay. 21, they're asking us again to distribute a negative. Okay. So it's going to be -1 times -2, -1 times positive 9x cubed, -1 times positive 8x to the 4th, -1 times 8x squared. 2x squared plus 6x to the 4th plus 8 plus 2x to the 3rd. And again, you can just lose those parentheses if there's no minus in front of that and there's no number in front of that, okay? -1 times -2 is going to be +2. -1 times +9 is going to be -9. -1 times a positive 8 to the 4th is going to be a -8x to the 4th. And then a -1 times a positive 8 squared is going to be -8x squared. Okay? So I just said -1 times a -2 is a +2. -1 times a positive 9 is a -9. -1 times a positive 8x to the 4th is a -8x to the 4th. -1 times a positive 8x squared is -8x squared. Or that's a minus sign. So I'm going to say minus negative is a positive, minus a positive is a negative, minus a positive is a negative, minus a positive is a negative, whichever way you prefer. Okay. Let's look at the degrees. This is a degree 2, a degree 4, a degree 0, a degree 3, a degree 0, a degree 3, a degree 4, and a degree 2. So I'm going to put it, I'm just doing the degrees so I can put the groups in descending order now. Okay. So now that I have the degrees, I'm going to start with the degree 4s. Take the sign. So it's 6x to the 4th minus 8x to the 4th. Good. Degree 3 plus 2x to the 3rd minus 9x to the third degree 2 plus 2x squared minus 8x squared. There's no degree 1, so we're just going to go straight over to degree 0 plus 8 plus 2. Good. Okay. So 6x to the fourth minus 8x to the fourth. 6 minus 8 is a negative 2x to the fourth. Positive 2x to the third minus 9x to the third. 2 minus 9 is a negative 7. 2x squared minus 8x squared. 2 minus 8 is a negative 6x squared. And then 8 and 2 is 10. Okay, so I put them in order so that when I combine those terms, it would be in descending order. But you don't have to. You can just say 2x squared minus 8x squared is negative 6x squared. You can go in that order too. And you can be crossing them off as you use them so you don't get confused. Anyway, guys, here's our last one. They're tricking us with language, English and math together. Subtract this from this. Okay? If I say subtract 4 from 2, do I mean 2 minus 4? Or do I mean 4 minus 2? Subtract 4 from 2. Subtract 4 from 2. Subtract $20 from your paycheck, right? You take your paycheck and you subtract the $20. So your paycheck, subtract $20 from your paycheck. Subtract $20 from your paycheck. Let's make us rich, right? Subtract $20 from your paycheck. You took $20 out of the big number, okay? So subtract 3x minus 30 from negative 2x plus 4 means this goes in the back. This is your subtract $20. 3x minus 30. It's hard because we're subtracting it from negative 2x plus 4. Subtract, right? Subtract $20 from your paycheck. Good? Hard. It's hard to think about English and do a new math skill. But that's what they're asking. Okay? All right. So we have negative 2x plus 4 minus the quantity 3x minus 30. So we have to distribute the negative sign. That stays the same, negative 2x plus 4 minus positive 3x, change the sign. Minus negative 30 minus a negative becomes a positive. Good. Now combine the like terms. Negative 2x and negative 3x are degree 1, variable x. And then plus 4 plus 30 are just constants. Negative 2x minus 3x plus 4 plus 30. Negative 2 minus 3 is a negative 5x. And then 4 and 30 is 34. So guys, that is it. I hope it made sense, and email me for sure if you have any questions about it. About anything at all about polynomials. Remember, we're just adding and subtracting them, so it's just combine like terms. If you have no like terms, you don't need to combine it. You can just leave it looking like this one, right? This one doesn't have any like terms. You can put it in order. Which one has the biggest? 10q squared r squared minus s cubed minus 12r squared plus 15. But you don't need to add or subtract anything because those terms aren't alike. Okay? Make sure all of this vocabulary makes sense. If not, you're welcome to Google it. Watch other people's videos. do what makes sense to you so that you are ready for the exam. All right. Have a good day.